Alright, good evening everyone. So for the experiment 2, power in AC circuit, we got 3 activity here. Alright, so we proceed with activity 1 first. So for the activity 1, we got this AC supply, we got the voltmeter to measure the power, and then we got the resistor. Okay, so first of all, don't forget to change the voltage RMS to 100 volt, and the frequency is change it to the 50 Hz as the instruction in the lab sheet, and then the resistor just 210 ohm. Alright, so run the simulation and then you will get the measured current and measured power, that is 47.619 watt. Okay, so stop the simulation and then change the value of the resistor to 390. Okay, alright, so run the simulation back and then we get the answer, that is 25.641 watt for the power. Alright, so stop the simulation and then change the value of the resistor to 470. Okay, and then run the simulation and then you will get 21.277 watt. Alright, so stop the simulation and change the resistor to 860 ohms. Okay, alright, so run the simulation and then you will get the measured power is 11.628 watt. Okay, stop the simulation. Okay, so for the series circuits, we need to change the R1 to 210 ohms. Okay, and then we need to change the R2 to 470. Okay, so run the simulation and then we will get the watt is 14.706 watt. Okay, so stop the simulation, change the value of R1 to 210. Alright, seems like that. Alright, and R2 is 860 ohm. Okay, so then you will get the answer. Run the simulation first and then you will get the answer, that is 9.346 watt for the current. Alright, stop the simulation. Okay, so for the parallel circuit, you need to change the R1 is the same, 210, and then the R2 we need to change it to 470 ohm. Okay, and then run the simulation and then you will get the answer is 68.896 watt for the power. Okay, stop the simulation and then change the R2 to 860 ohms. Okay, then run the simulation and then you will get the answer is 59.247 watt for the power. Alright, so that's all for activity 1. Okay, so for the activity 2, what we need here is AC supply, the voltmeter, and the one resistor and one inductor. Okay, so don't forget to change the voltage 100 volt and the frequency 50 Hz. Okay, after that you need to change the resistor, the value of the resistor to 210. Okay, like that, and then the load you need to change it to 0.4. Okay, done. So run the simulation and then you will get the answer, value of power is 35.004 watt. Okay, stop the simulation, change the same, this the value of resistor is same, and the load you need to change it to 0.8. Okay, then start the simulation and then you will get the value, that is 19.4 503 watt. Okay, stop the simulation. Change, it is same, the value is same. The value of inductor we need to change to 1.0. Okay, start the simulation, and then you will get the answer is 14.941 watt for the power. Okay, stop the simulation. Okay, that is change the resistor. Okay, now we change the resistor to 860, and the inductor we change to 0.4. Okay, run the simulation, and then you will get the answer is 11.383 watt. Okay, stop the simulation. Yes, the value of resistor is same, change it to 0.8. So the value of inductor. Okay, so run the simulation, and then you will get the answer is 10.708. Okay, stop the simulation, and then change the value of inductor to 1.0. Okay, run the simulation, and then you will get the answer 10.251 watt. Okay, alright, so the value that you will get in this voltmeter is in watt. So how to measure value in VAR? You need to substitute watt, substitute with tan theta, and then you will get the value of VAR. Okay, done for activity 2. Okay, so for the circuit 3, as we all can see here, it's quite different than circuit 1 and circuit 2 because of the difference of the polarity shown in the figure 2.4 in the lab sheet. It's different than circuit 1 and circuit 2, so you need to be careful on that. Alright, so what we do have here is AC supply, the resistor, and the capacitor, and also we got this voltmeter. Okay, and the circuit is on a series circuit. Alright, so first of all, you need to change the voltage to 100 volt and the frequency to 50 Hz. Okay, and then you need to change the resistor to 210 ohm, and then the capacitor to 2 microfarad. Okay, so run the simulation as usually, and then you will get the power. The value of power is negative 820.034 milliwatt. Alright, so stop the simulation, and then you change the capacitor only, change it to 4 micro. Okay, and then run the simulation back, and then you will get the that is negative 3.119 watt. Okay, so for value of the power. Alright, stop the simulation, and then change the capacitor to 4 microfarad, and then run the simulation back, and then you will get the answer for the value of power is negative 3.119 watt. Okay, so stop the simulation, then change the resistors, change the capacitor only. Still the capacitor, we need to change it to 8 microfarad, and then run the simulation, and then we will get negative 10.427 watt. Okay, stop the simulation. Then alright, so now start to change the resistor to 890 ohms, and then the capacitor change it to 2 microfarad, run the simulation, and then you will get the answer is negative 2.641 watt. Alright, so stop the simulation. Okay, the value of resistor is same, change the capacitor to the value of the capacitor to 4 microfarad, and then you will get the answer. Run the simulation, negative 0.283 watt. Okay, so stop the simulation, change it to 8 microfarad, change the capacitor to 8 microfarad, and then start the simulation back, and then you will get the answer for the watt, the power is negative 9.586 watt. Okay, so as we will talk about the formula for the measure the VAR, watt multiply by tan theta. Okay, so we will get the value of VAR. Alright, so we have done to activity 3, and last for the experiment 2. Thank you for watching.